Everybody. Um, Today we're going to pick up with the on function. On reminds me a little bit of converge because it's like doing a couple things at one time, all in a concise manner, like converge was. You can go back and review what converge does if you're wondering what I'm talking about. And the thing that jumps out at me right away is it's also known as the P combinator. And converge is sort of like the S combinator. In functional programming, or I guess it's combinator logic is the math behind it, but there's three combinators: the I combinator, which is identity; the constant combinator, which is the K combinator; and the S combinator, which is, like I said, sort of like converge. But with those three functions or three combinators, you can do anything. You can write any program. I dare you. It's going to be terrible as far as experience doing it like that, but it's possible. They're very powerful. And then there's other combinators that are not as common, but they exist, and this is one of them. They call it on. So let's start with the definition on this one. It takes a binary function called f and a unary function called g, right? And so you can see that right here. Here's a binary function f and a unary function g, and then two values right here, c and c. It applies g to each value. So it applies this second function to each of these values, and then it applies the result of each to f, right? So I would say applies f to the result. So it runs this function on these two values, and then it takes those two values and returns a b, which is this. So let me go through that a little bit more formally. And actually, I think it's easier sometimes to read function signatures from right to left. Like, so we're getting a b back. That's a value. And a function's a value, but I mean like a value that's not a function. Um, so we provided these two values, two of type C, and then we apply G to these values. So like this C becomes this, and we return an A. And this C becomes this, and we return another A. And here's the two A's that we return. So now that we've used this G function, the second function, to convert the C's to A's, we can take, and this is a unary function. Then we have this binary function that takes two A's and returns a B. And that's what this B is that we're returning. So I actually find these examples pretty good. So let's grab them and let's clean it up. All right, so this is our f right here, our binary function. It takes two arguments and checks if they're equal to each other, right? So that's our on function partially applied with the first argument, which is function f based on this documentation. A pretty simple function, right? Um, and I would say equal by two array. Like that just makes it clear when I use it somewhere else. And then here is so we need one, two, three, four arguments, and we're passing it one up here. And so this one takes the remaining arguments. So this is our unary function, g, where we're just getting the value of the A property in both of these objects, right? So this one has B0, but A1. This one also has A1. So together, this is our complete function. Um, and this is something else. This is another example. We'll just comment it out for the time being. So if we log this, ah, change the name of the function, try that again. Okay, so we get true. Because what it's doing is it's saying, first we get the value of the property A from this object, and that gives us 1. Then we get the property A, or the value of property A from this object, the second one, which is also a 1. That only takes 2 arguments. You can't do this with 3 values, not without looping or something. Um, but so now that we have 1 and 1, we can pass those values to A and B and check if 1 is equal to 1, and that is indeed true. So this could be really useful in certain situations. Um, we'll look at this other example too. I'm just going to take this and put this on one line so we can read it better. So contains insensitive. So in this example, um, we want to take these 2 strings, so here we're partially applying it with both arguments and then passing both values when we do this call. So partial application and then the rest of the application. So we pass the lowercase letter O and the uppercase um, string foo. And what we want to do is see if, let's see, includes, which one does it go? Returns true if specified value is equal to at least one element of the given list. Yeah, so we're checking if this lowercase o exists in this string after it's been lowercased. So first we apply it to lower to this, which just gives us back lowercase o because it's already lowercase. Then we apply to lower to foo, and it gives us lowercase f o o. And o does exist in here. It exists twice, so it is included. And then we get the result, which should be true. So let's save that and run it, and we get true. Yeah. So that's the P combinator. And yeah, so I don't know about you, but I feel really comfortable reading these type signatures now, and I find them to be very helpful. Um, and especially many times they can be polymorphic, so you don't have to specify exactly what values these things are. They could work for multiple values. For example, we're passing an object to C in the first example and strings to C in the second example. And we don't have to have multiple type signatures. And, it's very concise. Um, I think it's just too concise if you're unfamiliar with it. It takes some getting used to. Yeah. So that's on. Um, the next function we'll look at is called once. And this does what it sounds like it does. It takes a function and it returns a function that guards the invocation of the function such that the function can only ever be called once. So that's it. And then some nuance here. No matter how many times the return values function is invoked. Okay. The first value calculated is returned in subsequent invocations, right? So if you call it once, you call it once and it gives you the result. After that, it doesn't call the function again. It just gives you the result from the first time you called it. It does allow you to call it multiple times, uh, but it's only going to execute once, and that's the value you're always going to get. And before we even get into this, all they're doing is using a flag, a Boolean flag called called, and it starts as false. But when you call it the first time, it changes the flag to true. So next time, if called is true, it just returns the result. It's not a very complicated function to write, um, but they've written it for us. How nice of them. So I think about like a form submission button, like on a on submit event, you can call an event handler, but only once on submission. But I can't really demonstrate that here because I can't submit a form really. So let's use their example. So the cool thing about it, if you read the function signature, it takes this function and it returns the same type function. So literally all you're doing is wrapping any function inside a function called once, or maybe we should say we're decorating a function with a function called once. And we can make this point free. Well, all we're doing is incrementing. So we just say r.inc. And I'm going to even change this for no reason to inc once. So let's just actually put this all in here, give it a comma, right? And let's run it. And we get 11, right? So we take our inc function, wrap it inside once, gives us back a new function called inc once, right? So it returns basically the same function with like superpowers. So here we invoke the function inc once, apply it to 10, we get 11. Then here we are incrementing the value 50, but we've already done it, so it ignores it. It just gives us back 11. And then we take that and increment this number, but it doesn't matter. We get back 11 because it's only called once. And if we flipped it, what do we get here? Do that in your mind. We'll run it and we get 51 twice. So this function runs first, increments 50, we get 51. This function is applied to 51, but it was already called, so we get 51. Then we apply this function to 10, but it doesn't matter. It's still 51. So yeah, um, lots of different scenarios I could think of, really. None of them. I'm lying. I can't think of a lot of scenarios, but I could foresee business requirements where something needs to happen once and only once. And maybe even like if you had lots of if conditions or like branching conditions, and no matter what, you needed to do something one time and you could just do that before you called it. I don't know. I'm not making a lot of sense, but this is once, and then we're going to move on. This is another super easy one. It's the or function, and it works just like the pipe operator or the double pipe operator, like that guy, kind of similar to this one, but it's a function, so it's going to be prefix. So it returns the first argument if it's truthy, otherwise the second argument. It acts as the Boolean or statement if both inputs are Booleans. Okay, so it acts as the or if both inputs are booleans. What does it do if they're like strings or objects or something? Anyway, it takes two values, A and B, and then it returns either A or B. Which if it's truth, if A is truthy, it returns A. If it's not, it returns B, right? And then so their examples aren't all that useful. And I just realized Chris went through this in the original series along with and either. And then, anything that Chris did, I highly recommend you go and watch his video. Um, I just think they're better, honestly. Like the guy was a PhD student at the time in computer science. I'm just like this guy trying to make my way through this JavaScript game. Uh, yeah. So that said, I'm gonna move on. I think you know what OR does at this point. But actually, I want to find out what happens if as it acts as the Boolean statement if both inputs are Booleans. So, like, what if we do two strings? R dot or Bob Ross. Yeah, it returns the four. I mean, I guess you can coerce anything into a Boolean. So it's strange that they said that. If I did 3 and 0, I'm gonna get 3. If I do 0 and 3, I really hope I get 0. Oh, wait. 0 is false, so we get 3. Yeah, see, Boolean logic is so confusing to me. Yeah, if the first value is falsy, then we get the second one. Or the way they said it. If the first one's true, we get that. If not, we get the second one. Yeah, yeah, we get one. So yeah, that's or. Just nice that they've guess it's thorough. They want to recreate all the JavaScript operators, which, like I said, JavaScript operators are functions in JavaScript. They're implemented as functions behind the scenes. They're just prefix or infix notations. So it's kind of like doing it like that. All right, this would be backticks. In some languages, you can do it like that too. Um, but if you wanted to do it in JavaScript like that, you would have to do that. Cool. That's or. How many more do we have? We have two more O's. Okay, so this one gets a little bit more complicated because we're dealing with promises, but it's pretty interesting, right? So it's called otherwise. Before I get into the type signature, let's read the definition. Checking the time. Returns the result of applying the onFailure function to the value inside a failed promise. So this works, this is an asynchronous function. This is useful for handling rejected promises inside function compositions. So yeah, um, if you want to type something or compose something, this is useful. And then it says see also and then. And Chris looked at it then. I'm not sure if he looked at this function or not at the time. It's probably worth going back and checking. Um, so I'm going to go ahead and grab the code example and make it a little more readable. So this is a function that takes an ID and it creates a promise and rejects it right away. So we're not going to use this ID. So I'm just going to do this. And returns the string bad ID. So we're going to reject a promise. And then this is a essentially a constant function called use default, um, and it's going to return this object, first name Bob, last name blah 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 blah. Um, I think that's a Saturday Night Live reference, or is that Arrested Development? If you remember, leave a comment. I'm going to have to go look it up. Okay, so that's our on failure function right here. Failed fetch. Where is it? Or is this? Is this it? I'm not sure. To the value inside a failed promise. Okay, so this, the use default, is our on failure function to the result of a failed promise, and the failed fetch is what makes our promise fail. Let's see what they're doing with it here. Okay, so we've got a pipe. We're calling recover from failure with this ID 12345, and we're applying failed fetch to that. Failed fetch ignores the value and just rejects the promise, gives us back a bad ID. We're simulating a failed fetch. And here's where we call our otherwise, and we pass the use default. So we console log that. We can just log it because I have this function up here. And then let's see what we get. And we get our object, right? Yeah, we get our object. And then, which is, we've looked at this before, but this is like the dot then function. Then we use Ramda's pick function, and we grab the values of first name and last name, and that's what we get here. So, or actually, no, we don't grab the values of the first name, last name. We grab the whole we return an object with the first name and last name key value pairs. So, like, we're just picking things out of it. So, if we added another property here called age 32, and we run it, we're still getting that because we didn't pick the age. But if we did, we specify an array of keys as strings, then we would get the age. Yeah, it's pretty cool. So what if it didn't fetch? I mean, what if it didn't reject? What if we resolve? We'd have to resolve it with something. We wouldn't have to put a first name. What if we just resolved it with an empty object? Yeah, we get the empty object back because we're picking the first name and last name. So if we did first name Alice, just that, we get first name Alice. Yeah. But if we reject it, we get our default object back. So basically, this otherwise is not going to do anything if it receives a resolved promise, or not a resolved, a rejected promise. It won't do anything. Oh, sorry, I'm right. If we resolve successfully, this won't do anything. If failed fetch rejects, it's going to invoke the function that was passed to it, and it could get the ID. Uh, but in this case, basically, it's just, you could think of this as like otherwise default. It's almost like an else inside a promise. So with that being said, let's look at the type signatures. There's two. So the E here is the error. So if this is a function that takes an error from a promise and returns a B. Yeah. So this is our use default. Takes an error and returns a B. And the B in this case would be um, the default value, like the this object right here. So in order to do that, we need a promise that returns an error, and we'll call that type. That error contains type A. In this example, it's an object. And then it returns to us another promise. Interesting. I'm getting a little stuck on how to read this. So the function to apply can return a value or a promise of a value. Return to value or a promise of a value. Yeah, okay. So here we take an error and return a value. Here we take an error and return a promise of a value. And yeah, and it returns a promise of a value, B. And then we need our function that takes a promise. I'm just not sure how to read this. Maybe E is a promise? Okay, I see how that works. So, okay, so E is a promise, and A is the value that the rejected promise returns. Yeah, I'm a little confused on how to read this text signature after I just talked about how comfortable I was getting doing it. Um, However, without even being able, without me being able to speak all that intelligently about this type signature, I think we are able to understand how it works and how to use it. I understand the definition here. I understand the example. I was able to modify the example. So I call that 90%. 90 is still an A if you grade. So I'll leave this one here. If anyone can intelligently read this type signature, again, please leave a comment and educate me a little bit. Otherwise, and totally pun intended there, I'm going to move on to the last O function, which is called over. And over deals with these things called lenses, and there's like a whole bunch of related things. And I know that a lens focuses in on a section of an object, and then it creates setters and getters for those. Like you would make setters and getters and with a class. Um, and there's two variations: the type signature, one with functors and one without. I intend to go over this more thoroughly later when I understand lenses better. But for now, let's just focus on the first type signature and then the definition and the example. And then we might revisit this, but I'm not going to get into all these related ones right now. Probably do like a whole lens video. Let me clean that up a little bit. All right, we'll start with the definition on this one. It returns the result of setting. Okay, so setting like a setter returns the result of setting the portion of the given data structure focused by the given lens to the result of applying the given function to the focused value. So this is again one of these things where we're like, it's a little bit like converge, a little bit like on that we looked at. It's doing like multiple things, multiple transformations or calculations on the data. So let's grab this bit. So head lens. So without getting into this specifically, we're passing an index of 0, and it's called head. And we know what head does. Like we're getting the first thing in a list. And in this case, we're getting the first thing of a lens. And then we're going to run it, and then we're going to reverse engineer it. But we're going to need to log it to get boo bar baz. Right. So it uppercase this one and not these two. Right. Because we're taking our head lens, which is lens index 0. So we've got a list here, and we know foo is the first item in the array. So this is our head. We're going to uppercase that one, but not these two because we're focused in on the head of the array. So this one's uppercase, these two are not. And then we get uppercase foo, and then just the same value for bar and baz because that was not part of our lens. So we're not messing with that right now. Lenses I hear are very useful once you get the hang of them. They make or yeah, very useful, very easy to work with to do things that are common. So I do want to understand them better. And it may just be one of those things where people say it's complicated, but it's like not, you get all nervous about learning it. Um, but that's how that works. So if we look here, the first thing is going to be this lens. And I'm guessing the S is a string, but it may not be. I don't know. And A would be anything. And then our value, A to A. So that's this function here, r dot to upper, takes a value and it takes a string and returns the uppercase version of that string. And then it takes two S's. And again, that could be a string, but I don't think so. That wouldn't make sense. That would be too restrictive. So I think lens, maybe S is like the S in lens or something. Like N is too common for a number, E maybe error. I don't know. I'm just guessing here. But yeah, it takes a function and a value and then returns a value. Or it could take, if F was a functor and S and A is a lens, that's what I guess that means. Then we take a function that takes an A and returns a functor of A. So it would like, very common thing would be it takes an A and returns like a list of A's or just a list of one A. And then you take this value here, and instead of returning the value, you return a list of values or any type of functor. But I think that in functional programming, you're going to see that an array is most likely going to be your functor because an array is an example of a functor. Because a functor is a data structure that implements the map method. Yeah. So that's over. At least a brief first time example of over. Um, I I don't feel like I understand it well enough to try to come up with another example. Um, I could change this to lower. I mean, that's not going to do anything. I could change this to last, you know, but yeah. I wouldn't be using this in production just yet because I don't really know what I'm doing with it yet. And that's just going to be the case for some of these functions. But the vast majority of them I've been able to figure out without too much trouble. So that concludes the functions that start with the letter O. And then we're going to get into a huge section of functions to start with the letter P. If you look at my sidebar here, as I scroll, like my scroll thing, we're way past this would be the middle. So we're really getting our way through it. And for this one, like we've already looked at object and I think we might even looked at pair. Um, yeah, so we're making progress. And thank you for spending your time with me. Tell a friend, and I'll see you in the next video.